Hello everyone. In this video, we will take a look at how Anuta ATOM helps the network to remain compliant to your internal standards or regulatory standards. ATOM delivers compliance management in two different slices: service compliance and configuration compliance. Let's look at these in detail. Let us start with the service compliance. In one of the videos, we discussed how ATOM helps you to create services through its service orchestration capabilities based on Yang. Service compliance module of ATOM helps to maintain those services by continuously monitoring them to detect any out-of-band changes that would have occurred. Let us assume that we have an L3 service that has been created using ATOM service models. Here is the active service on the device, and the same can be seen in the archived configuration as well. The service is compliant as of now and can be seen in the service compliance view of ATOM. Now let us assume that some team member accidentally removes the IP address on the interface. How does ATOM detect this change and ensure compliance? There are a couple of ways ATOM can handle these. We can enable SNMP traps in ATOM to detect any device configuration changes. Based on this, the configurations are pulled automatically upon changes, after which ATOM passes through new archived configuration and triggers a service inventory to detect any changes to the service attributes. Once it detects a change, the service compliance will mark the service as non-compliant. The same can be seen in the service compliance view as well. The latest configuration shows the missing elements of the L3 service. ATOM also shows you the configurations to reconcile the non-compliant service. Here you can see the configuration that needs to be pushed to restore the L3 service. ATOM also helps to remediate these non-compliant services. If the changes made on the device are wrong, then you could choose to override the device or override the server, which is the ATOM in this case. Once the device configurations are corrected, the service becomes compliant again. The same can be seen in the service compliance view of ATOM. The other option is to schedule the configuration pull at regular intervals. After passing through the configuration, ATOM can immediately detect any service-related changes and then continues to work in the same format as we discussed earlier. Let us now look at the configuration compliance. We discussed the service compliance that helps you to maintain the service uptime. But there are other set of configurations in the network that may drift over a period of time, as they may not be directly tied to a customer SLA. These could be any of the day 0 to day end standards that you want to have across the network. Such use cases can be satisfied with ATOM's configuration compliance feature. Let's take a look at a couple of examples to understand this better. Let us assume that you have some clock and NTP policy to maintain across a region. The clock policy is to maintain a particular time zone, and the NTP policy is to point to a primary and secondary NTP server. In ATOM, you can create policies pertaining to these standards. Here you can see two rules, one for the clock and one for the NTP. Let's look at them. In the rule, we could choose the platform, have some rule variables where you could define some default values. For example, here we have defined variables for NTP associations and NTP servers. This is powered by ATOM's support for Jinja 2 templates. Then comes the conditions and actions. Here you could have multiple conditions listed. Let's take a look at the NTP server one. Here you can see standard CLIs that we expect on the devices. The variable substitutions will happen from the rule variable section. This standard configuration can be checked against a global configuration or a block of configuration. The match criteria can be defined as well. In the Actions tab, we can specify the match and the non-match criteria. If the exact CLIs are present on the device, then the action is continue, which means that the device is compliant to this condition and we can proceed to the next condition check. In the non-match criteria, we can set a severity to it and specify the CLIs that needs to be configured on the devices to make it compliant. Similarly, we have other conditions as well for the ACL that needs to be provisioned for NTP servers and NTP associations. Here is a clock template where the time zone policy is captured. Let us take a look at one more policy, where we are removing CDP and LLDP from all the public-facing interfaces. We have two different conditions here, one for CDP and one for LLDP. Let's take a look at the first one. Here you can see that we first detect the interfaces having public IPs. We also make sure that the relevant interfaces such as loopbacks and port channels are avoided. Then we look for CDP enabled commands under that particular interface. If it's a match, then we go ahead and do a no CDP enable under all those interfaces. Similarly for the LLDP enabled devices as well. Atom also supports Yang based compliance for devices that support native Yang. In this example, we're trying to ensure that the loopback 0, IPv4 and IPv6 addresses are always maintained. In the condition here, you can see that we have a XML template that captures the standard config we want to maintain. The scope changes to inventory data and the match criteria is now the template payload. We could also templatize it as shown in the previous examples. In the Actions tab, we see the fixed payload. Now in this example, we need to consider scenarios where only IPv4 would match or only IPv6 matches or both does not match. For that reason, we will need to introduce for loops and if statements. But how can one create the remediation payload? That is where the test engine is going to help you. Launch the test engine where you can play around with the variables, the input templates and values, etc. and then choose the device. And launch the test. You can use the output and start defining the remediation. For example, in this particular case, we can use the unmatched content to basically go ahead and start defining the fixed mutation payload that is seen here. So you may have several such policies that can be combined into a single profile as shown here. The combined profile can then be applied against a device or a device group or even a resource pool that will represent a region or a rack or a pod within your network. The compliance checks can be done on demand or scheduled against an already archived configuration or current running configuration. Let us execute this profile against a particular device. What comes out after the compliance checks is a detailed audit report that shows the entire set of policies and the compliance status of various devices as seen here. For this particular device against which the profile was run, the clock template we discussed earlier is compliant, but the NTP templates have returned a failure. All the fail conditions can also be seen in the report. Atom offers remediation of non-compliant devices. We can choose the device and just add a remediation job. Here you can see the devices and the non-compliant policies. On the right side, all the corresponding fixed CLIs can also be seen. The remediation can be scheduled or can be on demand. Once the remediation job is executed, Atom will then push the CLIs to the devices. Once done, the profiles can be run again to make sure that the devices are compliant. Once the CLIs are executed, the report shows 100% compliance for the policies as shown here. So we have seen how Anuta ATOM supports both service and device compliance management and remediation. Thanks for watching.